Hello, everybody. My name is Shauvik Choudhary, and I'm the founder and CEO of MoQuality. I'll be talking about taming testing clouds. So basically, in the last couple of years, as we all know, there have been several mobile device clouds that are there. So we'll be looking at how, as developers or QA, we can use these device clouds to leverage the devices that are present there. Before we start, let me just give you a brief overview about myself. This is my third Android summit and second time speaking. I spoke at the first testing track, which was 2 years ago, and I'm back again to speak this year. I have spent the last 10 to 12 years in testing. Most of the time on my PhD thesis at Georgia Tech, which was on cross-platform testing for web and then later on mobile applications. And over the last decade, I've worked at several companies developing testing tools at all of these places. A little bit about my company before we get started. So at MoQuality, we are trying to build AI-powered app testing tools. So think about latest cutting-edge tools that will help you do your testing more effectively and efficiently. We have two different products. The first one is a smart record and playback. You can simply plug on your phone, record any interaction, and play back it again and again on newer versions of your app or on different devices. And the second offering that we have, which is in beta, it's an AI-based exploratory testing tool. What it does is it looks at your existing tests and user sessions and expands from that and explores newer parts of your application to give you a visualization, as you see on the right, which we call as the app map. And it sort of gives you more coverage around your app testing. So having given you a brief overview, let's get started. So today's talk will cover these 5 different points. Since we are all back just after lunch, we'll start with like a brief refresher of the Android workflow and where testing fits in. Then we look at like a short overview of basics of UI testing, and then dive into device testing criteria, how to select devices for testing, and then we'll look at the different device clouds that are there and end with some recommendations. So let's get started. So Android workflow. So where does testing fit into the workflow? So if you Google for Android development workflow, this is what will come up on Google Android developer website, right? So it starts with you setting up your environment, then you write some code, then build and run the code, and then there's this iterative process of testing. So testing is not just done by itself, right? So when you're iterating, you're testing, you find some problem, you debug that problem, find the underlying cause, and sometimes if it's a performance problem, you have to profile your code and understand why your app is slow. And in this iterative cycle, you fix those bugs, and once you're ready, then you publish it, right? So this is the piece that we are going to be focusing on. And even inside testing, what are the kinds of tests that are there, right? This is the famous testing pyramid. For those of you guys who might not be aware of it, it essentially tells about the different kinds of tests that you can develop. So unit tests are at the bottom, and the area shows the number of tests that you should have. So ideally, you will have a lot more unit tests than some integration tests and a few UI tests to check all the different behavior. Now, unit tests are great because if a unit test fails, you know exactly which line of code or which unit the problem is in. So you will, and developers love to write unit tests. However, UI tests are closest to the UI behavior of the app. So it's closest to the business functionality that is being supported. And the topmost on Android, the top 2 UI tests and integration tests use the instrumentation framework and run on the device. So if a developer is using Android Studio, they can run unit tests locally on the JVM, versus integration and UI tests will run on a real device or an emulator. And this is the testing pyramid, or some people call it the mountain, right? And not every test could be automated, so you need to have sometimes some clouds on this mountain, right? Clouds of manual testing, which is sometimes impossible to eliminate. But it's also important because as long as we have humans using software, there will need to be some sort of human element for testing. But for today's talk, we'll be focusing on the UI testing part of it and look at how we can use public device clouds to run these tests. So that was a brief overview of the workflow, Android workflow, and how testing fits in. Now let's look at UI testing basics. So Google offers two different APIs for testing, for writing UI tests. The first one is called Espresso, and the second one is called UI Automator, or briefly abbreviated as UIA. So let's look at Espresso. If you're writing an Espresso test, essentially there are three different steps that you could write in a test. The first step is to find a view. So every Android widget actually is a subclass of the view class, right? So it's called a view. And you have a view matcher that finds a view given a hierarchy. And on that particular view, you perform an action, which is a view action subclass. And once you are done with it, you will run a view assertion, which checks whether the value is correct or not. So as a quick example, I'm pulling off the example from the standard Google testing website. Here, what we are doing is we are finding the view with ID name field. And in that, we are performing a type text Steve. So we are typing Steve into that particular view, into that particular text edit text widget. And then there is a button with the ID greet button, and we are performing a click on it. And at the end, the assertion, which is the matches, is displayed. So we are checking whether Hello Steve is displayed or not. I wouldn't go into details because if you are interested in Espresso details, there's actually another talk at 4 o'clock. I think it's 4:20 now. By Nick Tipatri, which is going to talk more about Espresso. So let's move on and look at the other API. So the other API, UI Automator, right? So if there is Espresso, why do we need another API, UI Automator? Well, UI Automator is a black box API. What it means is that Espresso, it runs inside the app. So it is aware of different things happening inside the app. On the other hand, UI Automator runs outside the app. It uses the accessibility API to understand what is going on and introspect the app. And it could be useful for checking things like cross-app tests, right? So all of your tests might not be just inside one app. You might want to launch it from the outside, right? For example, notifications. Those are things that you cannot test with Espresso. You have to use something like UI Automator. And in this example, what you're seeing is that we are, this sample test, what it does is it gets an instance of a UI device in the first two lines and presses the home button. So it's just simulating the pressing of the home button at the system level, not within the app. In the next step, what it is doing is it is finding a UI selector, a widget with the content description apps. So when you open up your Android phone, the button at the bottom, which has, it has the description apps, which is essentially clicking on, show me all the apps that are on the phone. And finally, what you're doing is you're click and wait for a new window, which means that you're waiting for the new window of apps to load, right? So essentially, this is a very simple overview of what UI Automator allows you to do. So now that we have covered these basics, let's go in and look at device testing. So on Android, the good thing is that we have so many devices, right? 137 manufacturers making Android, 9 versions of the operating system, right? But be different and not the same. That's what the motto of Android is. But that also creates an extra burden on developers because as developers in QA, we need to test on all of these different devices. So how do we select which devices to test on, and then execute the test and essentially manage all these tests? So for selecting devices, there are essentially 2 lines of thought, right? Like you want to test on all the top devices, right? And you can get these top devices from things like Analytics or Google Play Console. We'll look at all of these in the next few slides. But if you have an app in production, you might notice that although you have tested your apps on the top devices, all your bad reviews are coming from devices that you haven't tested. So you also need some kind of coverage of the different mobile phone makers or the different flavors of Android that are out there, right? So these are the 2 different things that you need to consider while selecting devices. Let's look at these in more detail. So first, when we start with Analytics, right? So this is the Google Play Console for an app that I had built. And this shows the top devices that are out there on which my app is installed. So sometimes if you're launching a new app, you might not have this data. But if you already had a previous app, you might have this. Or if you just launch, launch your app, and then you can find this, right? For the next version, you can use this, leverage this data to know what are the top devices that your users are using, right? So this is Google Play Console, which is available after you launch the app. You can also look at, for coverage, which is the second part, you can look at, the different versions that are out there. So all of these on the right-hand side are from Google Developer Dashboard, which says that all of these versions of Android are still out there, right? And the pie chart shows you which version is popular. So based on where you're targeting your app, you might want to consider the different operating system versions that you want to test on, the different screen sizes, densities, and so on. And on the left-hand side, there's an article which says that, we are in 2018, but the most popular Android version is from 2015. So that's the pain of testing, right? We have to support older devices as well. But keeping this in front allows us to slice and dice and then select devices, right, based on the different criteria of OS version, screen sizes, and densities. Let's look at another testing criteria. So this is the Firebase console, error console for the same app that I had built. So here, once you have a crash, you know that there's a problem a user is having. And from that, you can see which device and OS version they're having that problem in. So if you know that there's a problematic device out there on which users are facing problems, you might want to add that to your testing set, right? So this is another way in which you can select devices. Facebook has a unique way of selecting devices. What they say is that they have this categorization called as a device year class. So the idea here is that if you take any configuration that is available in the market, there was a time in the past when that configuration was the latest and greatest, right? So for example, if you consider dual core 2 GB, then that was the latest in 2012, right? So that's how they've defined the device year class. So for example, if you look at this configuration, you might want to say that I'm going to only support device year class up to 2011, not any older than that. And Facebook has a GitHub library that you can use inside your tests or inside your apps as well, where you can target and define your tests. So for example, this is mainly for developers, where if a developer wants to support some features only on certain device year class, they can do this. For example, this on the right-hand side, what you're seeing is that you first add this Gradle dependency to get that library. And then let's say you want to do some animation. But if it's the latest phone, then you do an advanced animation. Versus if it is a mid-year, year greater than 2010, then you do a simple animation. If it's a really, really old device, then your phone is too slow, don't do any animation, right? So this is sort of some sort of logic that you can also use in your tests and to basically check for different kinds of things. And on the left-hand side, that's the screenshot from their GitHub page. That's sort of the criteria they use to put devices in different device classes. Okay, so now that we know how to select these devices, let's look at public device testing clouds and how they stack up with each other in terms of features and pricing, and how does one use them, right? So for today's talk, I'm going to focus on mainly three public device clouds. The first being Firebase Test Lab from Google. The second being Amazon Web Services Device Farm from Amazon. And the last one being Visual Studio App Center from Microsoft. All of these three were actually startups that these companies acquired and made offerings based on that. And if you're developing apps, right, then you have either the Google Cloud account or the AWS account or the Azure account, right? So you have access to one of these. So that's why I'm going to be covering just the major three players. Having said that, there are several specialized device farms in the market. So for example, STF, which is Smartphone Test Farm, it's an open source software that you can download and run it locally, connect your devices, and get a device farm, in-house on-prem device farm. Similarly, there are several companies offering device farms as a specialized service as well. But for today's talk, I'm only going to be focusing on the top three. So just to show you examples, I'm going to be using the Google samples from Android testing. How many of you have seen this? Yeah, so this repository is from Google, and this is where they have examples of all the different kinds of tests that you can do. So for example, we are inside Android testing /UI /Espresso /basic sample. Right, one level outside, you will see several different example apps and tests that they have written as samples. Right, so this is great learning material as well. But we are going to use the basic sample as sort of our benchmarking app. So let's start with Firebase Test Lab. Right, this is from Google. The good thing is that it's integrated with Android Studio. So as an Android developer, if you have access to the source code, you can simply click a button and upload your app to Firebase Test Lab and start the tests from there as well. The good, unique feature that they have is that they have virtual devices. So how many of you have tested on emulators locally? Right? So that's a great thing, right? Being able to test on emulators, because emulators are infinitely scalable. You can have like multiple of them. It's all software, so it doesn't matter as much compute power you have. You can scale them. Versus a physical device, which you have to go to the store and buy it or order it on Amazon, right? What Firebase Test Lab has done is that they have virtual devices in the cloud, so you can run an emulator in the cloud and run tests on that. And as you might recollect from the previous talk from the Firebase SDK team. He mentioned that for stability and correctness, it's good to run your tests on emulator because they are infinitely scalable, cheaper than actually running tests on a real device. So this is sort of the unique feature that Firebase Test Lab has. They support both Espresso and UI Automator tests, and they support game loops. So if you are a game developer and you want to test a specific level of your game, you can define a game loop so that without actually trying to do a gameplay, because it's really hard to write a test for a game. But if you program it in a game loop, Firebase Test Lab will invoke that game loop for you. And finally, in the last I/O, they also announced iOS testing support. All the three device farms that I'm going to talk about have iOS testing support as well. But this being an Android conference, I'm only going to cover the Android testing part. So let's look inside this. So these are the screens that you see when you are trying to schedule a test run via the GUI. So you upload your app, you upload your test app, and then you go through this screen where you can select the different devices. So you select the different devices. You can also select orientations and locales. And based on your selection, it's going to make a test matrix and run your tests on all of these different configurations. As you might notice, on the left-hand side, we have all physical devices listed. Right-hand side are all virtual devices. So this is the emulators on the cloud. OK, so after the test is run, you schedule your test. They will run the test for you. And then after some time, you see the screen where everything is passing, right? Now, this is a sample test. Things are supposed to pass, right? So everything is passing here. If you click on one of these, you go inside, and you can actually see logs and performance statistics and so on. Now, performance statistics are only applicable on real devices because performance on the emulator doesn't matter. Because if it is slower, then who cares? That's not a real device, right? So emulator is mainly useful, as I said again, for stability and correctness issues. Okay. So now, how do you do this thing from command line? Because if you're running inside a CI, the only way you want to run it is not via the GUI. Why you want to run it via command line. So there is like one simple command line command that you run. It's gcloud firebase test android run. Type instrumentation, because it's a device test, instrumentation test. And then you can give it a device selector, where you give it a model, version, locale, orientation, and then you give it your app APK and the test APK. And this actually schedules a test and runs it. This is what you see on your command line. It will basically show you while the test is running, it will show you the status, and at the end, it will say 2 tests passed. Right, so it's really straightforward and simple to run it via the command line as well. So this is Firebase Test Lab for you. Now let's look at AWS Device Form. So now AWS launched a device form pretty early, like earlier than everyone. I think it was 2015 that they launched it. And so they are the most mature cloud device offering. They have the most number of devices. So they have 364 devices on their device farm. One extra feature that they have is you can, while you're starting a device session, you can specify things like GPS location, whether the Wi-Fi should be on or off, whether and so on. They do not support like emulators. That is one limitation. They only have real devices. Two things that they support that none of the others support is, first, they have manual remote access. So let's say something failed on a specific device, and you want to manually access that device, right? Instead of having to go and buy that device, what they do is they give you a remote desktop session into that phone. So from your browser, you can actually access the phone, see what is happening, and control that phone remotely from your browser. So that is the remote access session. They also have a feature that they just recently released this year, where you can actually buy devices on Amazon's cloud and actually establish a direct connection with them to do debugging locally. So what happens is, just as we use ADB to connect to our local devices, they set up an ADB bridge to their remote device. So it seems to you that that device on Amazon's cloud is local, so you can do debugging on it. So these are the two extra features that they have. Let's see how you schedule a test on AWS Device Form. They have a simple wizard-like flow where in the first screen, you actually configure and give it the test file. Then in the next screen, you basically select devices. They have a concept of a device pool where they suggest some devices to you. Otherwise, you can create your own device pool and create a pool of whatever devices you want to test on. Then, when you are creating tests, if your tests require some test data, you will add that here. You can configure in the different state of the different sensors. That's at the bottom. You can see you can set up your GPS coordinates and so on. And finally, when you schedule the test, this is the results you see. So this was interesting, right? So this was the sample test, but still there were some failures, right? So this is very commonly seen in Amazon Device Form, where sometimes the devices are not that reliable. So even the sample test would fail on some of the older devices or some of the cutting edge devices. So in this case, it failed on Amazon Fire, and it failed on Galaxy S9. This sometimes could be annoying because this is nothing wrong with the test or the app, right? This is something that is wrong with their infrastructure. So why is it failing, right? So it can cause some confusion with teams, but you get what you get, right, with these services. One extra, I think I forgot to mention, Google also has this, but you can actually go and look at a video. So you can play a video and see what actually the test was doing inside the app. So all of these services make a video accessible to you. So now let's see how you can do the same thing via command line. So again, one simple command line command. Here, the Amazon has an AWS resource number for any resource that you create. So if you create a new project, there will be a project ARN. If you create an app inside that project, there will be an app ARN. So you'll have to schedule a run with the app ARN, project ARN, device pool ARN, which is the device pool devices that you would run that test on, and finally you would give it instrumentation like a test details where you are giving a test package ARN and the type of the test. So let me show you screenshots. So in the first command, we scheduled a test run, and that just schedules it. It does not hang. It will just exit. And then you need to keep polling and checking whether the test is done or not. So in the next command, we actually checked, and it says that the test is finished, right? So this is how you do it via the command line. Now let's look at the last one, which is Visual Studio's App Center. Now App Center is the most recent offering, and they try to position their service as an entire CI/CD process, right? So it's not just for testing. You have to use it for building, and if you want to do testing, there is an option for that too, right? So it's mainly for your entire app ecosystem. One thing that they have is they support versions of from like Android 2.2.1. That's like pretty old, right? They don't support UI automated tests, and they don't have any smart robot testing or crawling facilities. So let's look at this. So this is how you get started. You would create an account or log in via your Azure account. You can select your Android, iOS, Windows, or Mac OS app, and then your tests could be written in the next screen. I think this is where you select your devices, and at the end you select your tests, which could be written in Appium, Calabash, Espresso, or Xamarin. So Xamarin is a framework that Microsoft offers, where you can write once, run anywhere. Just like React Native or Flutter, you can write your app in Xamarin in C# and compile it for Android, iOS, and Windows phones, right? So Xamarin also has a UI testing offering. But they don't support a UI automator. That's one thing that I noticed. So although you can get to this point, upload your apps and your test apps, but you cannot actually start the run from the GUI. You have to do it from command line. So then you open up your command line, you start your run, and then it would come back and complain that it does not include the test Espresso extension. So this is one thing that you have to do. So Microsoft requires you to add an extension into your test APK, right? And that allows Microsoft to take screenshots and stuff. So you have to make change to your test cases for being able to run it on this cloud. So once you add that extension, then it's straightforward. It's just similar to the others where you schedule a test, it gets run, and at the end you look at there's a link that you get where you can go and look at the test reports. This is how their UI looks like. If you open that link up, as you can see, all the tests are passing, so it's stable. If you click on one of them, you will see that it automatically takes the screenshot of the last screen, which is the last step of your test. So that's interesting. And if you want to take more screenshots, you can add like a command, and all those screenshots will appear here. So this summarizes the 3 test clouds that are available. Let me compare them for summary. So as you can see, Amazon Device Form has the most number of devices. They have 360 plus devices, and it's growing. Firebase Test Lab has the least number of devices, but they do have virtual devices as well. Microsoft App Center has 260 devices. The integrations that they have with Amazon Device Form are limited, but in Firebase, you actually have an Android Studio integration. So since Google makes Android Studio, obviously it is integrated with Firebase Test Lab. App Center, since it's Microsoft and Microsoft now owns GitHub, they have a very tight integration with GitHub, GitHub CI/CD process. What's unique about each of these is that for Amazon Device Form, you can have private devices just for you. You can have manual testing, which is the remote access session to manually inspect the devices. For Firebase, it's just the virtual devices that they have. For App Center, it's not just a testing solution, but it's more like a CI/CD process where you do build, test, deploy, and they have analytics as well. For pricing, all of them price by the minute, but App Center and Google, they advertise price by the hour. So I've converted everything by hour, and as you can see, Amazon is the most expensive. They're $10 per device hour, or 17 cents per minute. And Google Firebase Test Lab is $5 per device hour. They are actually $1 per virtual device hour. So that's even cheaper than everyone. And Microsoft is $3.3 per device hour. And Amazon Device Farm has a unlimited plan where you can get like 1 device slot and use that. So it's a single access connection. You can use that device slot to connect to any device and run your test cases. Versus Firebase, they don't have any unlimited plan. And Amazon has a private device lab. These guys give you a offering for $99 a month, but you only get limited 30 hours. So this is how all of these stack up with each other. So let's go to recommendations. So what do you do next, right? So my recommendations, from what my experience has been, would be that you should focus on testing early, right? Select a device lab, whether it's in-house or whether it's on the cloud, doesn't matter, but just select a device lab and set it up so that your engineers and your QA have devices where they can test. Of course, engineers should be focusing on writing unit tests, but UI tests are also important because it has the most business value since it mimics real users on how they will use your application. So test early. The next thing is test often. So if you have TDD and BDD testing practices, those are great, right? You write your tests or behaviors before you code. So that makes sure that you have your testing on your mind and you're always running your tests. If you don't have any CI/CD systems, continuous integration, then please set it up, because that will make sure that you're running your tests often on every, ideally on every check-in, you should be running some tests, at least making sure that your app builds. And finally, for device testing, for every build, it can get very expensive if you're running every build on all these different devices. So select a core set of devices, maybe 5, 10, whatever makes sense for you guys. Maybe it could be virtual. Many people just run on virtual devices on every build. But whenever there's a major release, you know which devices to run on. So try to get an exhaustive sample of devices that have good enough coverage, because that is the version that you'll be pushing to your public, right? So this is test early, test often. And at the end, you have to test sufficient, right? So testing can never be exhaustive. You can never test everything. So testing is always the best effort. So make sure you get to a level that you're most comfortable at. And finally, just don't do one thing for testing. For example, just don't do unit tests. You have to test at multiple levels, just like security, right? You have to cover all the holes and at multiple levels so that your users don't have a bad experience or your app is not compromised, right? So these are some of the recommendations that I will have. And that brings me to the end of this talk. As I said, I didn't want to give a sales pitch, so I didn't focus any time on what my company does. But if you guys are interested, please give us a try. We are a startup from Atlanta, Georgia, and trying to innovate in testing tools. Please give us a try, and you can reach out to me directly, Shauvik at morequality.com, or check us out at morequality.com. Thanks. Any questions?
So to use all this device form, we got to upload APK to the cloud, right? Do we have any security concern? Because some company may not feeling comfortable to upload APK outside the internal network.
Yeah, that's a fair question, right? And also, even if you upload it, it might not work. And we have seen that happen a lot of times. Let's say Capital One, right? If you guys upload an APK, which is a staging version from Amazon or Google's cloud, it might not be able to dial back home and connect to your staging servers because it's locked down, right? So those are also practical scenarios. What we have seen is that most of these 3 public clouds, right? I can't say anything about other companies, but these 3 public clouds, they have a fairly high level of security. All of them are SOC 2 compliant or so, right? So I would not worry too much about your app being lost, because anyways you're going to upload that app on Google Play or Apple Store anyways, and it will go out. And unless you have something super proprietary in your app, which you shouldn't have, all the proprietary stuff should be protected by your backend, right? So that is, so if you care too much about your app, then maybe you might not want to upload it. You might want to set up your own device lab. But otherwise, all of these are big names, right? They invest heavily in their security, right? Amazon Device Form, for example, has private devices. So those are an additional level, right? Like, because other devices, these are all public clouds. How they operate is, they will clean up a device, install your app on that device, run the test, and then clean it up again, right? That's how they do. But there could be a bug in the cleaning up. Maybe if you had a file and maybe the one who runs it later maybe gets access to the file. I mean, nobody knows. They try to make sure that it's secure. But if you get private devices on AWS Device Form, they make sure that that is just allocated to you. Nobody else gets access to that device.
Thank you. And for Capital One, I wish I can have the same reason they can be convinced. But it's very hard for a company, banking company,
Yeah.
to understand that there's a lot of productivity at stake. So in the case that we cannot upload, we cannot use all these tools, let's say, what kind of best practice do you know in case of what device we keep in-house? Obviously, I cannot keep 360
Exactly.
devices like Amazon. But if a customer saying, hey, particular device, the app crash, what usually
Let me answer that second. The first thing is, even if you're Capital One, right, you are probably using Google Cloud, AWS, or Azure, right? Maybe you're using AWS because that's the most popular. So if you're using AWS and you're using AWS Device Farm, you can set up a VPC so that your devices are accessing your backend securely. That is maybe one way. But to answer your second point, how can you make sure that you test on the latest devices? That is, I've spoken with several big companies, and many big companies would just buy a device. Like for example, Trello, I was speaking with a developer there. Coca-Cola, I was speaking with the director of mobile. They just would buy a device because for them, $200 or $800 is like way lesser than a bad customer experience, which will result in a 1-star review, right? So for them, they don't mind buying all the devices. So that is one option. If you have, there are also a lot of crowd testing companies. So where you can go and say that I want to test this app manually on this device, they will go and find a user or somebody who has that, and then connect you with that person. Now, do you want to make that trust that stranger who's going to download your app, do that testing for you, right? That's something that you have to answer, right? But other than buying that device, or hiring someone who has that device, like in a part-time capacity or a contractor, I don't see any other option. There's another third option where I was talking with, I wouldn't name this company, but what they did was they were having problems with a certain version of Android and a certain kind of device. So they were testing in production. It took them 2 weeks to figure out because they were putting a patch only for that particular device, testing what comes back, making a fix again, going back and forth. It took them 2 weeks to actually understand what was going on there and then develop a fix for it, right? So that is like the last nuclear option. You could do testing in production as well and trying out like real user devices. But at that point, you're not writing your tests. You're writing your tests as a part of your app, right? Not as a separate APK, right? So that might be an anti-pattern, but if you don't have that device, then what else can you do, right? So let me try to understand. So you're saying that if you don't have an integration, then it's faster. Is that what you're asking?
I see that you have a very limited options in workflow integration.
Yeah. So some of these are, like for example, GitHub, right? Even if there is no integration, you can use the command line tool to develop your own integration, right? So there is no UI for like a nice one button OAuth kind of integration, but you could essentially use the command line interface to develop your own integration. So that is not a problem per se. The problem comes with AWS where you have stability issues, where your tests are failing not because of your problem, but problem with their infrastructure. And that has happened a lot of times. I've seen, and I have several customers who have complained about that. The good thing is that they are if you have a support account with them, they are fast to respond and they will hopefully fix it. So it all depends on what cloud that you have bought in already. If you guys have made a heavy investment in AWS Device Farm, then might make sense to just explore that and see if they will, you guys being Capital One, they are more likely to service you than a small startup, right? So yeah. Any other questions? Cool, thank you guys.